Too often, even the best-intentioned projects to improve education can get started in the wrong place, leading off with an exciting new technology or an experimental new pedagogy. But any meaningful effort to improve learning needs to begin with a focus on the learner, and that focus needs to be maintained throughout the effort. Our California Learning Lab project begins with a focus on underrepresented STEM learners and asks, how can we improve learning outcomes for these students? Answering this question demands a larger community, one that's engaged in authentic research and is committed to improving learning. And to that end, our project brings together a diverse set of collaborators, educators, and researchers from Santa Ana College, California State University at Fullerton, the University of California at Berkeley, and from Carnegie Mellon University. And we give these collaborators access to some of the leading open and adaptive courseware platforms from the Open Learning Initiative and from Lumen Learning. Our project is built on 3 core themes. First, we know that open adaptive courseware can be effective in improving learning outcomes. But we also know that that same courseware, when moved to other contexts, isn't always as successful. We recognize that there's a need to customize and to change these materials, the ability to address different instructional practices in different learning contexts. But past evidence suggests that making these kinds of changes needs to be based on data, needs to be deliberative, and needs to be iterative. Our second theme is a growing movement in the open education community away from disposable one-shot assignments that don't have any larger meaning or usefulness for the students. And we know that there's an almost unending need for more opportunities for learners to engage in deliberate practice with meaningful feedback. Finally, our third theme is the recognition that experts simply do not see things in the same way that novices do. In fact, we might think of the process of becoming an expert as creating literally a new way of seeing the world. Yet we know that the novice perspective is an absolutely essential one to consider when attempting to understand and construct effective opportunities for learning. Our project, then, weaves together these 3 strands to facilitate greater participation from educators, from students, and even from everyday people in creating, explaining, and improving learning materials and learning models. We'll be investigating the impact of this participation in how well it supports California's underrepresented STEM learners. The project will start with existing open and adaptive STEM courseware from OLI and from Lumen Learning. We'll be specifically focusing on courses like chemistry, engineering statics, mathematics, computer science, and statistics. These platforms provide an integrated learning experience, embedding opportunities to answer questions and get targeted feedback into a larger problem-solving context. But equally important, these platforms are capturing fundamental information, both about learner interactions and about learning design. Our project will be adding dashboards and analytics to make these data more actionable for educators, tools to let them make customizations and improvements that are informed by evidence from past use. But we also need to layer on greater opportunities for students to contribute. We know that greater opportunities for practice can benefit our learners. And we also know that this act of creation and explanation is an exceptionally effective way to support learning. So we'll be exploring the creation of a new type of learning activity, ones that in turn ask students to write new questions, to create new explanations, and to develop new feedback. This act of creation will be supporting their own learning, but at the same time, it will be allowing them to develop new open learning artifacts that can be useful elements to include in future course releases. However, we know that the sheer volume of these new activities is going to make it difficult to review, difficult to give feedback, and difficult to select the kinds of activities that would be most useful to add to future versions of the course. We also know that our expert faculty aren't always in the best position to identify questions that speak well to the novice mindset. So to that end, we're also going to be creating mechanisms for other learners, peers, to help evaluate these student-generated activities. This work should be useful for the evaluator in that they're going to be creating their own explanations, but it will also be helpful to us in sorting these questions in ways that will allow us to see what other learners perceive as more or less effective. And this focus on the learner voice is going to explicitly offer us some insights into the novice perspective. Beyond creating these new activities, we also want to solicit learner perspectives to get a better understanding of our underlying learning model. So we'll be creating activities that ask students to explain some of the things that data has been showing us. For example, why is activity A harder than activity B? Or what skills do you see these two activities teaching in common? We're interested in the role of educators and of students, but we're also curious about whether there's a way for the broader public to be involved in improving these learning materials. To that end, we'll be investigating the crowdsourcing of new activities and new explanations, and the ways that this crowdsourcing might contribute to better materials and student success. We'll be using Amazon's Mechanical Turk to crowdsource broader populations to participate in these same activities and evaluations. Our research questions, then, are: do these types of community-sourced contributions to open courseware improve learning outcomes? What's the impact for students in participating in these creation and improvement activities? And can these student and community voices create better learning models, all in the service of improving outcomes for STEM learners? We need to recognize, though, that this work doesn't happen in a vacuum. Instead, it needs to happen inside of existing institutions, structures, and cultures. Carnegie Mellon's been fortunate to have a cultural anthropologist lead investigations into the barriers and facilitators of using these types of educational technologies. And so our current approach was designed to leverage that work, and as a final research thrust, we'll be investigating how these new participating institutions engage with these new community source tools and approaches, and we'll be attempting to better understand how this impacts faculty attitudes, interests, and larger long-term use of these materials. Overall, then, we anticipate broad impact from our project, including improved outcomes for all learners, new insights into the role of student engagement in learning. The project's going to produce an expanded set of open and adaptive courseware across a number of STEM domains. These coursewares are produced with an open license that will allow them to be used by future generations of California students. Finally, we hope to gain a clearer understanding of how to sustain participation in useful innovations across different post-secondary contexts. If you're interested in learning more about our project, please use a web browser and head to oli.cmu.edu/ca-learninglab. This will give you more information on the progress of the project and will show you opportunities for getting involved. Finally, we'd like to thank the state of California for generously supporting this work.